Welcome to Calculus 1. Again, we're still in Chapter 0, the preliminaries, working on Module 0.1.3. This is homework problem number 2. The solution for this problem is 4.8125 square units. Now let's go ahead and see how we arrive at that value. So again, we have this function f of x, which is equal to 4 minus x squared. And we want to estimate the area underneath the curve, but still above the x-axis, between the values, the x values, from 0 to 2. So what do we need? Well, this problem asks for 8 rectangles placed underneath. So there's going to be a little bit of computation here. And we're going to make our rectangles of equal length. That'll just make things more uniform for us. And again, we're looking on the interval from 0 to 2. So let's sketch out what that curve looks like. So here's our 4 minus x squared. Again, we're at a height of 4. We're over here at from 0 to 2. And we want this area in between. So how we're going to get that is we're going to start placing some rectangles underneath there. But we need 8 of them. So the easiest way to subdivide that is, well, if I subdivide the piece into 2, I have 2 even areas here. Notice I could go ahead and I could throw in 2 rectangles underneath that curve. Now if I subdivide each of those, okay, that gives me 0.5 over here and 1.5 over here. Notice that I can now construct 4 different rectangles. So you can see we went from 2 to 4. If we subdivide again, we'll get to 8. So we would go 0.25, 0.75, 1.25, and 1.75. Now if I draw those lines up, and of course this isn't perfect, it's just a sketch. Notice that this subdivides it into 8 different sections. Okay, now what we need to use is the right-hand values for each of these rectangles. So when you look at each of these rectangles, we're going to grab the right-hand side of the rectangle and we're going to see where its height is. So let me plot all these points here for the right-handed parts of the rectangles. And then what we do is on that interval we draw over the line. So each of these rectangles gets this height right here. Now notice that this is an underestimate of the actual value, but it's not too bad. Okay, so here's our rectangles. Let me sketch those guys in. So you notice that we've got 8 rectangles, and the last rectangle has a height of 0. Okay. So let's go ahead and let's look at this first area. So we'll call this region 1. And how do we find that? Well, we need to take its base length down here, which we call delta x. So we're going to take the base length. We're going to multiply it by this height length. Okay, and the height length is given by the right-hand value of the function on that interval. So the base length is delta x, and our delta x value here is going to be 0.25 because that's the length of the base of the triangle, or excuse me, the rectangle. Now the height is the function evaluated at, well, okay, let's call this first guy 0.25 x1, the second guy 0.5 x2, so on and so forth. So we're just calling them different x values. You can call them anything you want, A, B, C, D, Henry, George, Bob, it doesn't matter. So f at x1 is the function evaluated at 0.25. That's the right-hand value of the interval 0 to 0.25. So to evaluate that, we just plug 0.25 into the function of 4 minus 0.25 squared, and we'll get a value out here of 3.9375. Okay, now I'm going to make a mistake here, not on purpose. I've already recorded this and I'm going back and putting the audio in, and I know that I goof up here. So when I multiply those together, okay, I get this 0.98 something something, right? Okay. And watch what I put here. I put down 3.9375, which is the height. That's not the area. So I erase all this, and then I go to calculate the next one and realize later that I made a mistake. So we're going to come back and we're going to change that, where that arrow is, the 3.9375. I'm going to go ahead and I'm going to change that in a minute back to what it was supposed to be. But let's go ahead and look at area 2. And like I said, we'll come back and change that. So the base length here is, again, it's 0.25 because it's 0.5 minus 0.25. So the length of the rectangle, the base of it, is 0.25. So that's delta x. And that's going to be the same throughout. So I'm putting here that it's, again, delta x. Okay, now that's right a little bit nicer there. Now what's the height? Well, the height is the function evaluated at the right hand of that interval, and the right hand of that interval is 0.5. So it's the function at 0.5. So we're going to have 4 minus 0.5 squared, and that's going to give us a value of 3.75. So we'll take the base length of the rectangle, which is 0.25, we'll multiply it by the height of the rectangle, which is 3.75, and we'll get a value out here of, it's going to be 0.9 something here. Okay, 0.93. Let me go ahead and grab my calculator. Now here was what I'm noticing is that I made a mistake. Okay, so I said, wait, now let's go back and let's look at that 3.9375, because the area for the first rectangle should have been really close to the area for the second rectangle. So if I'm getting 0.93 for the second rectangle, then the first rectangle should be really close to 0.93, not 3 point something. So here I'm going back through the math to check to see where I made my mistake. And it was really just not an issue of computation, it was an issue of copying it down wrong. But again, what's important for you guys to notice is that as you start calculating these values, make sure that they make sense to you. That one didn't make sense to me, so I had to go back and I had to adjust and see where I made my mistake. Always make sure that when you do a problem that it makes sense to you. Okay, if the answer that you get out doesn't make sense, indicate that. Let me know on your exams, and that way I can give you some bonus, or not bonus points, but some partial credit. So here's the area. We got a 0.9375. Now the rest of this, we're just going to go through, and I'm going to go through each one of these so that you can see. So this video ends up being like 15 minutes long. But I'm going to go through here and show you how to get the rest of these areas. So here's the green one. So again, the length of the base is delta x. And we want to multiply that by the function height. Well, it's f at x3, and x3 is 0.75. So we've got 0.25, which is the length of the base. Okay, and that's given by 0.75 minus 0.5. So if you take those two values, subtract, you get the length of the base. I mean, that's common sense. So we're going to take that guy and we're going to multiply it by the height, which is the function evaluated at 0.75. So we've got the function evaluated at 0.75 gives me that number. Okay, so I'm just putting the computation down here. And when we do the whole thing out, we get this area of 0.85 something or another. Okay, so we'll go ahead and we'll 0.859375. So we'll go ahead and we'll put that guy up there. And that's the area of rectangle number 3. And we just keep repeating this process until we're out of rectangles. 8's a lot. What if I had asked you to do I don't know, 30 or 100. You'd be here forever. That's why for calculus we try to look for patterns so that we don't have to do this out every time. But that's not saying that this isn't worth doing, because doing this computation out here is going to help us when we start working on integrals and Riemann sums. And it'll make things in that section will make more sense because you've done this. So this is well worth playing around with. So to find the area of the orange rectangle, we do the computation. Again, 0.25 for the base. The height value is f at 1, which is 3, so 0.25 times 3 gives us 0.75 for the height. Excuse me, for the area of that rectangle. Now these are all in square units, right? Okay, so we've got really 3 more because the last one has a height of 0, so there's no area there. So our base length is 0.25 here again. We multiply by the function at the right-hand side of the interval, which is 1.25. Okay, we do our computation out. And if you fast forwarded to the end, I don't necessarily blame you at this point, because this gets rather tedious. So we get 0.609375. Put that guy up there. 2 more left. Okay, so we'll go ahead and erase that. Give us some room again. So rectangle number 7. Do it in... Oh, sorry, number 6. Do it in purple here. So base value 0.25 again. 4 minus the right hand side of that base is 1.5, so we'll square that guy. Make sure you do your algebra out here. It's not really even algebra, to make sure you do the computation correctly here. Okay, so that gives us a value of 0.4375, so that's the area of rectangle number 6. Rectangle number 7 will be here in blue. If I do a whole lot more rectangles, I'm going to run out of colors. So that's delta x times f at x7. So it's 0.25 times 4 minus the right-hand value of that, guys, is 1.75. Square that guy, because that's the function. And so do our computation out here. Now, I want you to notice that each one of these rectangles, the area is getting smaller, and that makes sense. If, for example, the area from rectangle number 7 had been more than the rectangle for number 6, I would have known I had done something wrong, and I've got to go back and check my computation. So that's really the last one we got to do, because here if we look at rectangle number 8, it's flat, so it has an area of 0. Now what we need to do is we need to add all of these guys together. So let me circle what we're adding here. Every single one of those numbers, because those are all the areas, gotta add them together. So I'm going to pause the video here, and I'm going to add them together on my calculator, and I'm also going to check them with some calculus techniques. Okay, and so let's go ahead and pause this. Okay, now I'm back. It's nice how fast that works, huh? Okay, so I'm getting 4.8125 square units. So hopefully you got the same value.